Okay, so we're going to look at parts of a circle. First, you need to know all of these names for these different parts of a circle. Let me just rub that one out. So maybe write them down, copy them down somewhere, and you need to memorize them. So there definitely should be some you know here already. Just have a look and see if you can, if there are any you know. I'm going to tell you which the three easiest ones are, which is this one. Definitely come across these before. So do you know what we call that part B from the centre to the edge? It's called the radius. Do we know what this is? From one side to the other through the centre is the diameter. All around the outside of your circle is the circumference. Now these ones may be new to you. Part A, this part of your circumference is called the arc. Part G, if you've got a straight line touching the edge of your circle, it's called the tangent. Part H, a line from one side to the other, not through the centre, is called the chord. And here we have so it's like a slice of pizza there. See, it's going from the centre, it's like a slice of pizza. It's called a sector. It's like the area of like a pizza slice or a bit of pie. Imagine cutting it through the centre. And here, you see we've got a bit of an area which is cut off by a chord. That's called a segment. Okay, so I'd like you to memorise those. And then on the next page, you've got a bit of a test, see if you can remember them. So memorise those. Once you're done, put me on pause and see if you can name all of those things. Okay, I'm going to start going through the answers now. For the first one, you should have got this one is a tangent. This one here is the sector. Radius. Diameter. Arc. Chord. Segment. And circumference. Okay, there are a couple of properties you need to know regarding tangents and circles. Copy these two down. Let's look at the first one. Copy it down. Put me on pause. Unpause me when you've copied it. So it's telling you that two tangents from a point to a circle are equal in length. So it's telling you that that there is equal to this bit here. So can you see we've got like a kite? So let's just have a look at this in a bit more detail. That's a kite shape. And it's symmetrical. So if I cut it through there, it'd be perfectly symmetrical. Let's just look at that again. Two tangents from a point to a circle. So it's from there to there. It's the same as that bit from there to there. Copy this next one down and we'll just discuss it. Here you've got tangents are perpendicular to the radius at the point of a contact. So you can see you've got a tangent here that touches a radius. They're perpendicular, so it means it like forms a right angle. It basically means that this is a right angle there. So let's just have a look at why you need to know that. What kind of questions you might be asked. So you might be asked to find a missing angle. Let's start with this one first. So remember we discussed that this is a right angle here. and you're trying to figure out angle X. So just have a little think yourself. Hopefully you're thinking, well, angles in a triangle add up to 180, don't they? So 180, take off 90, take off 42, gives you your missing angle is 48. And let's have a look here. Here, right, well, so we've got a kite, we've got a four-sided shape. What do angles in a four-sided shape add up to? 360. But you also know, haven't you, because you've got these radii here, you know, they're 90. So we've got 360, take off 90, take off 90, take off 36, gives you that angle there as 144. Right, okay, have a go at these, put me on pause, unpause when you're done, and I will discuss how to do them. Right, okay, so for your first one, we've got a right angle here, 180, take off 27, take off 90, gives you x is 63. Yep, you've got your right angle there. Angles in a triangle add up to 180, 180, take away 68, take away 90, gives you x is 22. What about this one here? This one's a little bit more tricky. So angles in a straight line add up to 180. 180 minus 154 gives you this one here is 26. We know this is 90 because we've got a tangent to a radius. So what's this one? Well, 180, take away 26, take off 90. Angles in a triangle gives you this is 64. These angles on a straight line add up to 180. So 180, take away 64, gives you this one is 160. Part D. Tricky, very tricky one again. This angle here is 90. Angles in a triangle add up to 180, don't they? 2x add x is 3x. So we know 3x plus 90 equals 180. So now it's an equation we can solve, isn't it? So let's take 90 off both sides and divide both sides by 3. Well done if you got that one right. E. So 90, 90. Angles in a four-sided shape add up to 360. 360, take away 150, take away 90, take away 90, gives you x is 22. Similar with this one, 90, 90, angles in a four-sided shape add to 360. So 360, take away 15, take away 90, take away 90, gives you x is 165. Okay, what about this one here? Well, this is 90, this is 90. What's this one? 360, take away 90, take away 90, take away 160, gives you 20. Opposite angles are the same, so x is 20. What about this one here? Again, 90, 90. Let's get this one first. 360, take away 90, take away 90, take away 23, gives you this is 157. And then you've got angles round a point add up to 360. So 360, take away 157, gives you x is 203. Now you might see this applied. So to not looking at angles, looking at missing lengths more. So again, so remember when we'll look at these two examples and copy them down, then I'll give you some to look at yourself. So for question 1, we've got a right angle triangle, haven't we? Why is it a right angle triangle? Because you've got a tangent touching a radius. Hopefully you can see now, have a look at, think about what type of maths we're going to apply to this. Hopefully you've seen it's Pythagoras. A, B, C. A squared plus B squared equals C squared. 3 squared, remember our C's are hypotenuse. That's your hypotenuse, right? 3 squared plus 4 squared is 25. Square root of 25 is 5. Okay, now here we got a right angle triangle as well. But this time we've got an angle involved. What happens when it's an angle involved? SOHCAHTOA. Let me write SOHCAHTOA down. So, opposite, hypotenuse. What uses opposite and hypotenuse? It's sine. Sine 63. Opposite goes at the top because it's first. Hypotenuse goes at the bottom. So we're going to times them. Don't forget to close your bracket. Sine 63 on your calculator, that is sine 63 times 8 gives us our x. Then x to each other, so you times them. So x is 7.1. Have a go at these, please. Put me on pause, unpause when you're finished. Okay, so these first three are all Pythagoras. 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 First one, so you've got your A, B, and your C. Got 5 squared plus 12 squared equals x squared. (169) equals x squared. X is 13. Square root, x is 13. Part B. Don't forget your hypotenuse, your C is your 20 this time. So this is x squared plus 8 squared equals 20 squared. Your hypotenuse has to be here, doesn't it? X squared add 64 is 400. So we've got to solve this equation now, haven't we? How do we solve it? We take 64 off both sides. And then square root both sides. 18.3. So this one here is very similar to C. Your hypotenuse is your 30. So that needs to be your C here. So you've got a squared plus b squared equals c squared. 20 squared plus x squared equals 30 squared. 900. 400. Take 400 off both sides. Square root both sides. Gives you x is 22.4. So 12, I think all of these are going to be SOHCAHTOA. First one is missing angle. There's your right angle, because it's your radius touching your tangent. Opposite, hypotenuse. Opposite hypotenuse is sine. Sine x. Opposite goes at the top. Hypotenuse goes at the bottom. Don't forget to get a missing angle. We need our sine to the -1, don't we? So shift sine, that divided by that. Which gives you 27.4. I'm just going to change the colour. For B, you've got your right angles there. Always put your right angle in with these. Your right angle is where the radius touches the tangent. And put them all in for here as well. So opposite, hypotenuse. Oh, it's sine again. Opposite hypotenuse. Sine x. Opposite goes at the top. Hypotenuse goes at the bottom. Sine to the -1. 12 over 15. 53.1. What about this one here? Oh, we've got the adjacent this time. and the hypotenuse, so it's cos. Cos 25, we've got the angle this time. Adjacent goes at the top, hypotenuse goes at the bottom, so we've times in them. $18.1. Just going to snip this on the next page to give myself some more space. Okay, so here. Now, for these ones, we're going to need to split them. I remember me telling you they're symmetrical. We're going to split them to get a right angle triangle. And now, can you see? If I take out my triangle, there's my right angle. There's my 4. There's my x. But that's half of 30, isn't it? So that angle there is 15. Then let's label them. Adjacent, opposite, tan. Tan 15. Opposite goes at the top. Adjacent goes at the bottom. We divide them. 4 divided by tan 15. 14.9. Again, we're going to split this in the middle here to get our right angle triangle. So we can only use SOHCAHTOA and Pythagoras in right angle triangles. Got our x there. We've got 14 here. Don't forget we need to halve our 124 there, don't we? Which is 62. Let's label opposite, adjacent. Opposite and adjacent. Tan. Tan 62. Opposite is 14, goes at the top. Adjacent is x, goes at the bottom. So we're going to divide, aren't we? 14 divided by tan 62 gives us our x is 7.44. And our last one, again, let's split it. That's 8, that's 30. Now, that's our full angle, but we're going to need to work with this angle first. We've got our opposite, we've got the adjacent, so it's tan. Tan, y. Opposite goes at the top, adjacent goes at the bottom. So I need tan to the minus 1 of 30 divided by 8. Tan to the minus 1 of 30 divided by 8 is 75.1. But that's just this one. X is double that, isn't it? That's 75.1 and that's 75.1. So our total answer for X is 150.2 because it's double your 75.1. Okay. Hopefully you found that topic okay. It's good revision for SOHCAHTOA and Pythagoras as well. Okay, thank you. Bye.